Hey, Ms. Brown's class. Today we're going to talk about proportions and how they relate to slopes and how we're going to make graphs with them. So let's say I'm given a word problem that's about a kid, John, who has a little side business and he likes to mow lawns for money. However, he's only willing to mow 2 lawns per day. So, in one day, how many lawns can he mow? 2. Okay, because every one day that he works, he can get 2 people's houses done. All right? If he works for 2 days, that's 2 lawns plus another 2 lawns, okay? Or 2 times 2 gives us 4 lawns that he's done now in 2 days. This process is going to continue. So in 3 days, I could do another 2 lawns, which would give me 6. Now notice that I skipped a bunch here and I went down to 10. Hopefully you're noticing a pattern that the lawn column is twice the value of the days column. 2 is 2 times 1, right? And 4 is 2 times 2. So now I'd say to myself, 2 times 10 is what? So after 10 days, John should be able to mow 20 yards. Okay? Now we can represent all of that on a graph. Okay? You've seen it on a graph before, but we haven't used the word slope yet. Okay? I know that they touched on this in 6th grade, so let's add a little bit more to that. So let's say John is sick, he didn't want to work at all. So he worked 0 days, so how many days can he, or how many lawns can he mow? None. Okay, 0, 0 would put him at mowing no lawns in no days, okay? But on the day that he is feeling good, so day 1, he was able to mow 2 lawns, right? After day 2, I'm just using this chart, I'm able to go up to 4 lawns. After 6 days, running out of room here, after 3 days, I mowed 6 lawns, okay? So now what I would say is that you would want to connect these, make a line, okay? It doesn't have to be perfectly straight, in theory it is, but Ms. Brown can't draw, and that's okay. Okay, so this is showing you the rate of lawns that he's able to mow depending on how many days he's willing to work. Now, typically when we talk about a proportional relationship, it has to go through the origin, which is 0, 0, meaning he worked 0 days, so he mowed 0 yards. Now, there are other types of problems with slope that are not considered proportional because they do not go through the point 0, 0, and I want to talk about those. Let's pretend that you babysit for some money. All right, so I charge $9 per hour to babysit, okay? But I also want the parents of the kids I'm babysitting to give me $5 of gas money. Now, they do not have to pay me that money for the gas for every hour that I'm there. I only drove to and from their house 1 round trip, so I don't need to do gas multiple times, just multiplying the hours multiple times. So what this means, okay, I could actually write this out as a problem, okay? I start off, okay? $5 is a flat rate that I expect the parents to pay me, okay? That's a guarantee. Now, the amount of times I get paid 9 hours depends on how long I stay at that house. So I would say 9 times x, because x is unknown. X means how many hours did I stay at the house babysitting. We're not sure of that. Now this alone, I'm not sure how to graph that yet, okay? We haven't learned this. But what I can do is make a table of values. So just like we said, this is like what we did with the John problem with mowing the lawn. Okay, so how many hours did I work and how much money do I make? All right, we're going to assume I'm not working 0 hours, because if I work 0 hours, do you think the parents are just gonna hand me $5? No, because I probably didn't go to their house, so that wouldn't make sense. So I would start at what happens if I work 1 hour. So what you do now is you plug in 1 here. You'd say, what's 9 times 1 plus 5? So 9 times 1 is 9, plus 5, that means I would make $14 for being there. If I worked for 2 hours, that would be 9 times 2 hours, plus the $5 I want for gas. So 18 plus 5, now I'm making $23 to be there. If I worked 3 hours, 9 times 3 plus 5. 9 times 3 is 27. 27 plus 5 is $32. All right, when you look at this graph, or when you look at this table, 1 times 14 is 14. Now 2 times what is 23? That would be 11 and a half. So this is not a constant rate of change, or not a constant rate of proportions, okay? Because I'm not dividing by the same number each time. 14 times 1, or 14 divided by 1 is 14. But 23 divided by 2 is not 14. You would always need it to be the same number in order to be a proportion. So this one, not a proportion, but that's okay. We're still working with slope. Slope is a constant rate of change. So now let's look at this. 14 plus 9 is 23. 23 plus 9 is 32. So is it constantly going up by the same amount? Yes. So the rate of change is 9, because that's how much I'm charging per hour. So this 9 is actually going to be your slope. This 5 is what's called an intercept. An intercept means, where does my sloped line cross through the y-axis? Okay. So this means I'm going to change the scale that I have here, because it's too small to fit all this. So if I want to go up to $32, maybe I can count by 5s or something like that. 5, 10, 15, 20, 25, 30, 35. That works because I'm going up to 32. I need to have something reasonable. But the number of hours I work can just count up by 1, that's fine. You can change your scale, what it is on the x-axis versus what it is on the y-axis, but I can't go 1, 2, 3, 9, 10, 11. I can't just skip numbers in there randomly, okay? My x has to be consistent with all the x values. My y has to be consistent with all the y values. So, if I worked 1 hour, I made $14. I'm putting that dot right below the 15 line because it didn't quite make it. At 2 hours of work, I was at $23, so that's between 20 and 25. And then at 3 hours, I made $32. If I'm to connect these, I should see a straight line. Okay, so my rate of change, or my slope, was 9. Why? I went up 9, I went over 1. I went up 9, over 1. So this is something that we're actually able to count out, okay? If I had smaller boxes here, I'd literally be able to count it, but you can say to yourself, what's the difference between 14 and 23? Isn't that difference 9? Yes, okay? So slope is written as, what's the change in y over the change of x? So when y goes up by $9, how many extra hours do I have to work for that? So what's the difference between 2 and 1? That's 1 hour of work. So $9 for every 1 hour. That's what your slope means when you put a graph into words, okay? Believe it or not, these pictures do actually have meaning. So that's what you're working through, okay? Biggest thing that you need to know for this week's lesson: y over x sometimes people call it rise over run equals slope.